You to put it into slope-intercept form. The way it's given to you is, that's actually called general form. General form is when you have all the terms on one side and 0 on the other side. You're going to look more general form in 7.2. But for now, that's the form sometimes that you, when you're writing an equation for a situation, it comes up in. But there's an advantage to having it in slope-intercept form. Number one, because it's pretty easy to graph in slope-intercept form. And number two, because if you write it as y equals, you could use technology, you could use your calculator to graph it. Usually, a lot of graphing software programs don't graph in this form, but they do graph if you isolate the y, right? Slope-intercept form is when you have that y isolated. When it's in this form, you could create a graph. Now, we're not going to create a graph with a grid. We're just going to create a rough graph over here. You have two things there. You have 3/2 x, and you have those two terms. What do those things represent? Once it's in slope-intercept form, what can we say here? Like, this is broken down into, it asks you a different question for each part, but what's the slope of the line when it's in that form? What's the slope? This number, right? That's the slope. The number in front of the x is the slope. Slope is 3/2, or you could actually divide that, right? 1.5. What would the units on that slope be? If the two things you're comparing are, what do we have here? We have x is number of balls thrown, or number of throws, or whatever you want to call it. We'll just put throws. And then the vertical is profit in dollars. So this is, I'm going to put dollars here. Put profit in dollars. What would the units on that slope be? If you have dollars and throws here, number of balls thrown, what are the units on this slope then? How do you find the units on the slope? If you know the two units here, remember the slope is rise over run. So it's just going to be the vertical divided by the horizontal. The slope of that thing is going to be dollars per throw or dollars per ball thrown. We can just put dollars per throw here. All right, let's put ball thrown because that makes more sense. Okay, maybe those are weird units, but those are the units here, right? This is dollars of profit per ball thrown. Every time somebody comes and plays the game, they get $1.50 out of it. Okay, that's what that's saying. Leave some space here. For every ball thrown, they make $1.50 profit, right? Let's say their profit increases $1.50. Okay, $1.50, $1.5. What is a y-intercept? If you have it in that form, remember, maybe some of you are uncomfortable with the y on the right side. You can rewrite that the other way around with the y this way. If you don't recognize it, you can write it that way. Y equals 3/2 x minus 300 if you don't like the y on the right side. That's exactly the same. This was the slope. What's the y-intercept? If it's in that form, what's the y-intercept? That number, right? Negative 300. It's important to realize it's a negative 300. Y-intercept is negative 300. What would the units on that be? It's the y-intercept, so it's going to have the units that the y-axis has. What are the units? Dollars, right? What does that represent in this situation? Yeah, that's going to be kind of like the startup costs, or you could explain it a bunch of different ways. It's the cost before anybody's played the game, right? Cost of running the thing. I don't know. Startup costs. Startup costs. Okay, maybe the safest way to say it is it's the cost before, it's your profit negative, right? If you have negative profit, you're losing money, right? It's the cost before anybody's played the game, right? Profit if no one plays. I don't know, something like that, right? Lots of different ways you could say it. Negative 300. If you're drawing the graph of the thing, if you're trying to draw a graph from those two things, if you have the slope-intercept form, you can draw a graph by starting at the y-intercept. So at the y-intercept is negative 300. It's going to be right here, right? Now this is just a rough sketch of it, but negative $300. Which way is the line going to go from there? The more people play, the more throws that are made. Which way is the line going to go? Down like this, up like this, straight across. What happens? Your profit goes up the more that it's played, right? That's going to go up that way somehow. Now we don't know what this is. That's the x-intercept, right? We have the y-intercept here, is that point. We have the slope of the line, which is the rate that it's going up at. From our grid, there's no grid here. We can't tell what this point is, but you can find the x-intercept a different way, right? It says here, the break-even point is the point at which the money raised equals the money spent. In other words, money raised equals money spent. Break-even point is when your profit is how much? If somebody says you're just breaking even in your business, what does that mean? Your profit is zero. You haven't lost money, but you haven't gained money. Okay? Break-even point means, and you should know that, right? I mean, that's a pretty basic business thing, even if you're not going into business. It'd be a good idea to know what that term means. Break-even point, or to break even, means your profit is zero. Profit is zero on the graph. Where is that on the graph? Profit being zero? Right there, right? This is a profit of zero right there. So you want to find the x-intercept. Okay? Find x-intercept. If you had the graph with a grid, you could just look at the graph and see what the x-intercept is. But we don't have a graph with a grid. The way you can find it is find it with the equation. Okay? Okay, use the equation. Since our graph's only a rough sketch, right? Very rough sketch. You can use the equation. You have y equals 1.5x minus 300. What's true about the coordinates of this point here? You don't know what the x is, right? You have two coordinates. You don't know what the x coordinate is, but you do know what the y coordinate is. What's the y coordinate at the x-intercept? What is y here? Y is 0, right? You know that y is 0, but you don't know what this is. So you can do that. You can do that in the equation here, right? You substitute in y equals 0, and then solve it. Solve for x. That'll tell you the x-intercept. If you want to find the x-intercept, put y equals 0. If you want to find the y-intercept, put x equals 0. Okay, so if you substitute that in, so you have 0 equals 1.5x minus 300. So that's what you're doing. You're substituting in 0 for y. How do you solve that equation? Now it's just a grade 8 equation to solve. How do you solve that? Actually, I guess it's a grade 9 equation because it's got a decimal in it. But what would be your first move here? Getting the x by itself? Yeah, take that, add 300 to both sides. You're going to end up with 300 equals 1.5x. And then divide both sides by 1.5. If you divide both sides by 1.5, you get something like 200, I think. Okay, what are the units on that? On the x-intercept? It'd be a shame to get something wrong on the provincial exam if you got the number right but the unit's wrong. If it's the X-intercept, what are the units on that? Look back at the graph if you need to. What are the units on the X values? Number of throws, number of balls thrown, whatever you're calling it. When 200 throws are made, 200 balls are thrown or whatever. Right, that's the X-intercept. Okay, that's the meaning of the X-intercept there, right? Again, just keep in mind, one of the big concepts here is at the Y-intercept, X equals 0. At the X-intercept, Y equals 0. You can use that fact to find it in an equation, right? Since you're finding the X-intercept, you can put in Y equals 0. If you have an equation you want the Y-intercept, you can put in X equals 0. That's important to know for what you're going to do. All right. The other two examples that are there, well, first of all, there's a your turn question that you may or may not have done already. But there are two other examples here. One of them is you're given data and you're to graph it, and then you decide whether you're joining the points or not. And then it's going to ask you, what's the slope? What's the y-intercept? What does it represent in each? And then write an equation. Okay, so this is writing the equation from the graph. Basically what you did in the warm-up today, only it's in an actual applied situation, right? When you're describing what the slope is and what it represents, include the units, right? Don't forget to put the units here. Don't forget to put the units here. That's important to know. And then you can, that's just thinking about using the equation and the graph to find a missing point. There's a related question there. And then the last one, you're given the equation, but you're not given the slope. Okay, you're missing the slope there, that m value. I think we should certainly be able to finish this section today. And if you are ready to get going on the next section, you can feel free to start that too, okay?